Hello, my name is Robert Kayser, and this is Project 2 for IFT 510. It is a Batcher Banyan program. So this is my 8x8 program. Basically what it does is it takes a random group of non-repeating numbers from 0 to 7 and puts it into a list right here. And that list isn't in any particular order, so it's going to come out looking like a mess. This is my 16 by 16. This is my 8x8. But it's going to come out kind of looking like a mess, like this right here. So after I get that list, I sort it into ascending order, and then I convert that list of integers into a 2D list of binary numbers and the binary bits of those binary numbers. The next part are these switches right here. These are off switches for the input nodes. So input nodes, I mean, for my 8x8, my input nodes are A1, A10, A11, A20, A21, A30, A31, A40, and A41. Each time one of these nodes is used up, it locks it off, so that way the program has to look for the next available node. And it checks the first bit for each of the numbers to get it through this first layer of switches. That's where the magic's happening. And the way that works is, so say I have these three numbers, 001, 010, 000, 001, and 010. So 000 is 3 zeros, so it's going to go through A10, B10, and C10. 001 is going to go through a top 0 slot, but it can't go through this A1 slot because this A1 slot has been locked off by this computer magic right here. The A10 or the 001 is instead going to go to the A21, the B2 or the A20, the B20, and then up to the C11. And then since these two slots are locked off, this 010 is going to have to come down here to A30 to come up and go around. So if we were to, if we were to remove that 001, so now that slot's freed up on A20. So 000 still uses its slot and it locks it off. And then the 010, instead of using A30, can now use A20 and get to where it needs to go. And that's basically the way it works. As a slot's used up, the slot is locked off, and then the next available slot is used. And there's enough slots for the 8 digits on my 8x8. And this is my routing fabric. So, but like I just explained, each one of these, I've been calling them machines. Each one of these is an input port on the A1 row, each of these upper level ones. And each node output has access to other specific node outputs. So A10, here, let me clean some of this up. A10 has access to B10 and B11, B10 and B11. B10 has access to C10 and C11, C10 and C11. And B11 has access to C20 and C21. So C20 and C21. So that's our 0 slot on A1. And then for our 1 slot on A1, our one slot on A1 has access to B30 and B31. B30 is C30, C31, and B31 is C40 and C41. And they all work like that. For the leading 1 bits, once we get to a leading 1, it rolls back over to the top of the stack of nodes, and it starts using the empty 1 inputs and outputs. So we go from the 000, the 001, and then the 010, and we get to the 100. It crawls back up here to A1, and follows it from there. And we can see it work. I have it set to, well, I had it set to 4, but this is like the 5th time I've recorded this. Setting it to 4 makes it a bit easier to read. We can see we have the random list, then we have the sorted random list, and then we have the 2D list of binary numbers and then binary bits. And then we can see what it spits out here. We'll get some new random numbers and do it a couple times. Okay. So we'll walk through these just so you can see how it works. Hold on. So for our first one, we have 000, so that's just going to go all the way across. And then we have 001. A10 is used, so we'll use A20. So 0, 0, 1. And then we have 110, 1, 1, 0, and then we have 111, 1, 1, 1, and then we can follow these and see if we got there correctly. So for this first one, we had A10, B10, and C10. So A10, B10, and C10. For this second one, we had A20, B20, and C11. So A20, B20, and C11. And then for the third one, we had A11, A11, B31, B31, and then C40, C40. So we got the 6. And then we have A21, A21, B41, B41, and C41. So it routes it based on what's available at the time, and then it also has like if the traffic's full, and then it's just the static route for everything. So if we set it to 8 by 8. Then it just fills up all the slots. And my 16 by 16 is basically the same exact program. I just have more switches for that first row because there's an extra layer of nodes. For the 16 by 16. So instead of just the A1 through 4, it's now A1 through 8. There's this this crossbar switching, linking these two 8 by 8 networks together. And to do that in the programming, I don't really know how to program, so I ended up just repeating and filling it out correctly with the correct links. So it works almost identical to that. We did have to increase the number of bits we needed for this. So this one is 4-bit instead of 3-bit. And then let's set it to 8. So we still have a random list, and it's still, sorted into ascending order, and then we still get the 2D list of binary numbers and binary bits. And then it just works it out the same way it did before. The same way it did on the 8x8, it just has to go through this extra layer of fabric right here to get these two networks linked into one. That's basically all I did. And we can run it with the full 16. So we can see we get A1, A2, A3, A4, 0, A5, 0, A6, 0, A7, 0, and A8, 0. And then it restarts back up at the top with the A11, A21, A31, A41, all the way to the bottom. And that's basically my program. Thank you very much.